Hello, welcome to Module 13, and our focus in this module is going to be Linux security. How to secure a Linux system. And there are a few tools or systems that we are going to analyze during this class. The first of them is going to be Sudo. Then we'll take a look at the Plugable Authentication Modules subsystem, or PAM, followed by the inetd and xinetd and app armor. This is actually one is the evolution of the others. Then we're going to look at the SSH protocol, focusing obviously using a tool to implement that protocol. So we're going to take a look at the Open SSH server, which is the implementation of the SSH protocol in the Linux system, along with the SSH command line tool, which is the SSH client. And lastly, we'll take a look at Iptables. So let's start with Sudo. And by now, we already know how to use Sudo. It's actually a very simple tool, very straightforward, very friendly. We used it several times. Actually, we use it almost all the time. Whenever we have a administration tool or command that we have to invoke, since we are using, as you can see here, a regular user, and we can actually identify that by the user ID, it's above 999, that means it's a regular user. Regular users cannot run administrative tools, but I can do that if I precede a command with sudo. For example, if I try to list the content of the /root directory, which is not permitted, as we can see, but if I precede this command with the sudo command, then I have to inform my password. There it is. Okay, so now I can. That's because actually my user, my regular user, Linux, invoked that command. But then the sudo tool, because that's what I said, I want to run this command here, pass this command actually as a parameter for the sudo tool. So what I'm doing is my regular user is actually invoking sudo. Sudo will see, okay, can this user here, Linux, invoke this command? And if it can, whom is he going to run it? As whom is it going to run it? So, well, to run ls/root, you have to be the root user. This means that the Linux user will only be able to run ls/root if this user here is configured in the sudo tool as a user allowed to run commands as root. So how can we verify that? Okay, the simplest way is there. When you have the sudo tool in your system, in your Linux system, it will create a group called sudo. Every user that belongs to the sudo group will be allowed to run any command in the system as root. So this means that if there is another user, not just the one that you created during the installation process, but let's say that you create another user, so you use user add or add user tool to create a new user. And now you want to allow that user to, well, basically you want to make it a administrative user as well. Well, you can simply add that other user to the sudo group as well. But users that belong to the sudo group will be allowed to run any command as root. What if I want to configure, for example, a few commands, a few tools? I want to allow that new user to run only these specific commands. Then you have two options. One is editing the /etc/sudoers file, but that's not recommended. And the other one is running the vsudo command. This is recommended. It will open the /etc/sudoers file. And the way this file is configured, or the way that you can configure sudo is, you have four options, four columns here. You can configure a user and a command or a set of commands per line. For example, this first line here, I am saying that the root user from any machine, all machines, it doesn't matter which host name he's using, can run as any user, all users, any command, all commands. Well, that's pretty obvious, right? The root user is supposed to run everything. But now if we scroll down, we can see here that we have the percentage sign, which stands for a group name, not a username. So there is a group called admin, and users that belong to the admin group will also, from any machine, be allowed to run all commands. And once again, for the sudo group, users that belong to the sudo group, which is that configuration that we just saw, if I add a user to the sudo group, same thing. It will be allowed to run all commands. But let's take a look at this configuration that I added here. Here I'm saying that this specific user, Linux, so you can specify user or group. If it's a group, I have to precede the group name with %. Can, from any machine, as any user, run. Now, I'm saying that the Linux user can run /usr/bin/passwd space anything, asterisk, that means anything. But I'm associating this user with this specific command. That's not really the case because my Linux user actually belongs to the sudo group, which means that this user will be allowed to run anything. But if I use another user here, for example, Ubuntu, if I create my Ubuntu user and I do this, I'm saying that the Ubuntu user will only be able to run /usr/bin/passwd. Let me give you an example of when you'd use that. Let's say that in your company you have an intern, and that intern is supposed to run the backup scripts every day. Well, to run a backup script, you must have some level of permission. Let's say that to run this specific backup script, you have to be the root user because it's going to copy files that only the root user has access to. Obviously, you're not going to give the intern the root password. What can you do? You say that his user, which is a regular user, will be allowed to invoke, and then you have the path to the script, to the backup script here. That intern will be able to invoke the script as the root user, but he's not logging as root. Then, as you can see down below, right here, you hit Ctrl X to exit, and it's going to ask you, do you want to save these changes? Why? Okay, this is the file name. Yes, I'll just hit Enter. And done. It's configured. So that's how you can use sudo in a more advanced way. Now, another very useful and important resource that we have in regards to security in the Linux system is the Plugable Authentication Modules. It's called a subsystem because it's such a powerful tool that controls or can control steps of several different other softwares. For example, if I when I when I start my machine, my Linux machine, if it's configured to boot into the graphical interface, I will face a login software, a login interface, a login screen. That login screen is the authentication screen for the GDM. GDM is the GNOME Desktop Manager. That is the graphical interface that comes in most of the Linux distributions. So if you want to use the graphical interface, probably you're going to face GNOME or KDE. Well, so that varies, but those are the major ones, and which is not important right now. But what matters is you're facing a screen that is the authentication system of a specific tool, or it's the authentication tool itself. Now, that authentication tool is just the interface. It will just ask for your username and password. It's not the tool that is actually taking care of the authentication process. The authentication process is taken care by the Plugable Authentication Modules subsystem. In a Linux world, PAM takes care of sessions, different steps of many softwares. Not all of them, but most of them. So what I mean is, if we take a look at the /etc/pam.d directory, we can see some files here. This is how PAM is going to take care of the authentication process, authorization process, and session opening process for these tools. AT, which is the scheduler. For example, change password, although it's not very much used. Usually you use passwd. You also have cron, you have cups, which is the printing system. And let's take a look at for example, the Gdm Auto Login. So the Gdm Auto Login is the system that will take care of how a user can authenticate and check if that user is actually authorized to open a GDM session. So PAM is the software that is taking care of how a user can log in my system, into my system. It's also because there is a difference between authentication and authorization. Authentication is simply the step where you are informing your username and password. PAM, that system, in this case, that tool, for example, Gdm Auto Login, will simply receive those credentials and pass it over, hand it over to PAM. PAM will simply, at first, verify if that login and password are correct. If it is correct, then it's past the authentication phase, moves forward to the next phase, which is authorization. So the authorization module will verify if that user is actually authorized to use that system. Because I can have, for example, I have 20 users in my system. They're all valid, but I just want 2 or 3 being able to actually open my graphical interface, using my graphical interface. Well, you have 20 users that will be able to authenticate, but only 2 or 3 users that will be authorized to use that system. And then I have the session opening, which controls, that's the PAM module that will control how that session will be made available. For example, do you want that user to be able to have access to some specific features when opening that session? Do you want to allow that user to use the browser when opening a new session? Do you want to create environment variables when that user opens a new session? When a user opens a new session, how long can that user remain inactive before being forcibly logged out? So it's all session related, and PAM can control that. So PAM has several modules, several different APIs, libraries that will allow you to control a bunch of stuff. Now, additionally to those three different phases, you also have PAM modules to control password change. So let's say that a user wants to change its password. If you want to define, for example, that a password must be at least 16 characters long, among those 16, there must be at least one capital letter, one lowercase, at least one number, at least one symbol. You have the PAM modules to control that. So for example, if I edit the /etc/pam.d/passwd, which is the command that we use to change a user password, oh, we can see that it is actually invoking the common password file. So let's take a look at the common password. So we can see here, let's find this line here, for example. When a user tries to change the password, the PAM Unix module will be invoked. You can configure more than one module for the same phase. In this case, when a user tries to change the password, not just PAM Unix module will be invoked, but also PAM deny and also PAM permit. Oh, and there is another one down here, PAM GNOME keyring. So you have different modules because each module has a specific capability, has a specific set of possible configurations. If there is one configuration, one setting that you want or you need and is not available, for example, in the PAM Unix module, well, we'll have to find a module that actually deploys that feature that you're looking for. And then you add another line invoking that module. Now, clearly, you have specific configurations for specific modules. You have to search for the documentation to know how to configure the module or the modules that you want. And you can always refer to the kernel.org website, which is the official Linux kernel website, and the PAM modules are described there, at least most of them, the official ones. Now, PAM is a very useful resource, but there are some features that cannot be controlled by PAM, because PAM can control authorization, authentication, session, and password changing, but it cannot control how a service or software will run. For that, we have other solutions. The first one, let's say the ancient one, the first network service controller that we had was the inetd, and it's not available anymore, at least not by default. There. But if you want to install it, you can. And it's this one right here. Now, all these tools, whether it's the inet, xinetd, or AppArmor, what they do is they will allow you to set up different features regarding network services. For example, let's say that you have a, not telnet because it's very old, but let's say that you have SSH running, a SSH server running in your machine, or you have a web server such as the Apache HTTPD software running in your machine. There's a bunch of different configurations for security reasons that you may want to establish. For example, when I have my Apache HTTPD web server running, I only want to allow up to 50 users simultaneously. I only want to allow clients establishing connection from this range of IP addresses. I only want to allow 5 concurrent connections actually transmitting. So there is a bunch of security and performance features that can be established. Now, if that software allows you to implement those security that you're looking for, that's great. But you cannot be certain that all softwares that you use will actually allow you to establish those features or those policies. Because of that, you have a centralized network service controller, which once again can be INET, very ancient, very old, very limited. Then it evolved to XINET-D, right here. And as the description itself says, replacement for INET-D with many enhancements. And then we have another tool that is the improvement of XINET-D, but focusing even more on security, not so much on how to manage the services, how to control how the services are running in your machine, but more security related, which is the APP Armor. Right there. And in modern Linux distributions, you can have 2 default network service controllers. You can have the APP Armor, or you can have the SE Linux, Security Enhanced Linux. Most distributions nowadays are using APP Armor, although there are some that are using SE Linux. The default in Ubuntu 18.04 is APP Armor. Now, if we look at /etc/apparmor.d, we can see the configuration files for different services. For example, we may remember from our last module that we checked for the DH client process. We wanted to know if our network was configured to automatically and dynamically receive network configuration, such as IP address, DNS server, router, or if we had to manually configure those network information. And we saw that DH client was actually running. The APP Armor is actually controlling DH client. And other services that you may install, you may run, are also being controlled by APP Armor. For example, TCP dump, CUPS. As you install additional services, additional network softwares, you will see additional files here in the /etc/apparmor.d directory. Now, another very useful tool that we have, actually it's a protocol, Secure Shell, SSH. And it's not installed by default. There it is. We can see that it says none, so it's not installed. First, let's understand what the SSH is. SSH is simply a secure shell, a protocol that will allow you to perform remote access to a SSH-enabled machine, which means that you have the client SSH and you have the SSH server. So you have the SSH client, the SSH server. The server must be the machine that you're willing to access. So let's say that you want to get access to a SSH, to a Linux machine. You have to make sure that machine has the Open SSH-server package installed. Now, if you are the client, you can see here that by default it comes with the SSH client. What it's going to do is you'll be able to establish a remote connection from your machine. You'll be able to get access to the console, so the command line interface, and also the graphical interface if you want to. So we have to keep in mind that SSH is not only, although most of the times that's how it's used, but it's not only used to get access to the command line interface. You can also perform remote access to the graphical interface. Now, what is the difference between SSH and, for example, Telnet, which is a very old protocol also used for remote access? The difference is that Telnet does not implement cryptography. SSH does. So that is why whenever we talk about security in Linux, we have to consider SSH because it allows you to remotely access a machine. For example, from your home, you have to access the company server to do something. For example, once again, issue the backup script, run the backup script. So you have to get access to that machine and start that script, run that script. But if you're using Telnet, all commands, every key that you hit will be transmitted through the internet or through the LAN, whatever you're using to get access to that machine, in clear text. Obviously, that's not what you want. You want that communication to be ciphered. SSH does that. So the simplest way to run SSH is SSH and then the IP address of that server. For example, I want to access this machine. Well, I can't. The port used by SSH, port 22. Why can't I? Well, I don't have the Open SSH server package installed. Okay, so let me install it. There it is. Now, what if I try to SSH my machine? Oh, so now let's take a look at what's going on here. The authenticity of host, and then there is the IP address, can't be established. So it's not that port 22 is closed. It's just saying, okay, the key fingerprint is, and then there is the fingerprint. There is a signature that uniquely identified that machine that I'm trying to access. So basically what it's saying is, okay, this fingerprint here is not recognized, which means you are accessing this SSH server, which has this fingerprint, but this is a new fingerprint. I cannot verify the authenticity of this fingerprint. Do you still want to continue? Do you want to add this fingerprint to our fingerprints database and make it a reliable server? Basically, it's warning you, saying something like, you are trying to access a server, but I cannot actually confirm that is the server you're willing to access. You may be suffering a man-in-the-middle attack, for example. But let's say that you do know that, okay, this is the server that I'm trying to access. I just don't have that server's fingerprint yet because it's the first time I'm accessing it. So if you want to continue, you answer yes. It's going to ask for the user password, and there, you're connected. I am going to disconnect, exit, and I will try to establish that connection again. Now, it's not saying that the fingerprint is not recognized anymore. It is, it's in my database. And then I pass the password, I inform the password. If it matches, then there it is, I'm connected. Now, let me disconnect. Okay. When I do SSH space the IP address, yes, I am in this machine and I am actually trying to establish a connection to the very same machine. Yes, that is correct, but it's just for display purpose. Basically, if you're trying to access another machine, you'd just inform that other IP address. So it doesn't matter if I'm using my own IP address. I'm still using the SSH protocol to remotely connect to my own machine, to the same machine. But it's through the network, via network, port 22 SSH connection. Now, there are a bunch of other features that I can use here. First of all, let's say that I'm trying to access a server, but I don't want to connect to that server via SSH using my current user, which is Linux. There is a very high probability that there is no such user in that server. I have my Linux user here in my machine, but I'm trying to access a SSH server that has other users. Well, in that case, you'd have to inform that other user at that IP address. Let's try. So now I have to inform the root password because that's the user that I'm trying to log in. But no, I can't, although the password is correct. Let me just make sure, let me cancel this. So let me redefine the root user password. And let me try once again. No, I still can't. Why? SSH has a configuration file. And that is where you configure how your SSH server is going to operate, how your SSH server will accept connections or not. And there is a bunch of different parameters that we can configure here. For example, in case I want to change the port my SSH server will listen to, you have to uncomment this line and change this port number. In case, let's say that you have two different interfaces, network interfaces, you just want your SSH to listen to one interface. You uncomment this and you inform the IP address of that interface right here. And there is a bunch of other possible configurations here. Here, permit root login. If you want to allow root users, clients to connect using the root user, then you have to uncomment this line and change it to yes. However, you're not supposed to accept that. You're not supposed to allow that. There are two different proper ways of allowing SSH clients. One is that guy will have to use a regular user. For example, I'm logging in as a regular user Linux. And now that I got access to that machine, remote access to that machine with a regular user, then I can either invoke administrative tools using sudo, or I use this su command to become root. So if you have the root user password, then you can do su space dash. It's going to ask for that user password. And now I am root. That is one. Another one is configure the pair of keys. So you can do SSH keygen -t RSA or DSA. It doesn't matter which standard algorithm, cryptography algorithm you want to use. Nowadays, RSA is the default. You hit enter. It's going to say, okay, do you want to generate, can we use this file here to hold your private key? If you don't want this file name here, and you can see that it's in a hidden directory, .ssh, dot means it's hidden, and the private key is going to be stored in that file. I'm going to cancel this. Then it will generate that private key along with the public key. So if I take a look at my /home/linux/ssh directory, it's empty. So let me create it. Yes, define a password for your private key. Okay, I defined that password. And now it generated the private key and the public key. There it is. Private key and public key. Now, what do I have to do in order to be able to remotely access using SSH and using my pair of keys and not a user password? The private key is yours. Now, this is where it may get a little bit confusing. Since we're trying to remotely access a server, you may think that you have to copy the private key to the server because it's a server. Servers have private keys. That is not the case. You have to keep your private key with you. It's a private key and it's yours, so it should not go anywhere else. The public key is the one that you have to copy to that server. Once you copy this file, the public key, to that server, then you have to copy that file to a file called authorized keys. So I would have to copy this file to the SSH server. Then I access that server and I copy that file to, I do a cat. Okay, so let's say that I copied via network, I copied my id rsa.pub file to my user's home directory. Now I have to do a cat and redirect it to, the /home/linux/.ssh/authorized keys, like that. Now I have my own private key, I have my public key, and I copied my public key to the server that I want to access. I get access to that server, and I copied my public key to the authorized keys file. Let's say that I need to access 5 different servers. You're going to copy the same public key to those 5 different servers and copy the content of that file, public key, to the authorized keys files of all those 5 servers. Now, one question that is very common is, okay, I generated my private key here and I have my public key here in my local machine, and I need to copy the public key to that remote server. Well, I can't use CP because CP copies a file from one directory to another directory in my own machine. It's a local copy. If I want to perform a remote copy, then I can use SCP. SCP is the CP command, but performing it via network and using SSH protocol, which means that you're copying a file through the network, and that copy is done using cryptography. The way it works is SCP, the source, in this case where the file is and the file name. So it's in my home linux.ssh. What is the file name again? ID rsa.pub. I want to copy this file to the server 10.0.2.15. Now, to copy this file, I want to use my Linux user. And where is this file gonna go? I want it to go to /home/Linux. Now, it is actually asking me for my private key passphrase because I created my private key, and also that server already has my public key. But if that's not the case, it will just ask for your user password. It would copy the file, then you would access that server, copy the public key to the authorized keys file, and then you'd start using your private key. Okay, and lastly, we have to take a look at the IP tables, which by default comes in most Linux distributions. IP tables is simply a tool that will work on the layer 3, which means that it's analyzing all packets, network packets, or datagrams, as you want to call it. All network packets that is arriving to your network interface or leaving your network interface or passing through your network interfaces. So for example, let's say that someone is trying to establish a SSH connection to your machine. Well, then you have packets coming in because that remote node, that remote machine, is sending packets to your machine. For example, just to try to establish a connection. Just trying to establish a connection means there are packets coming in. Now, in order to accept or not that connection, you have to at least send a response to that client or possible client, which means that you are sending packets. So input, output. But there is also the forward chain. It's called chain. Forward chain is when your machine is working as a router or gateway, which means that packets are coming in and those packets do not have your own machine as the final destination. Your machine is being used as a gateway or router, so your machine has to receive those packets and then forward them to the destination. So let's say that you have 2 different networks. network A, network B. And this machine right here is the router or the gateway used to connect those two different networks. If a client from network A needs to send a packet to a client from network B, it will actually need to send that packet to this machine that we see here that is working as the router. This machine will receive that packet, forward from one interface, forward that packet through the other interface that is connected to network B. So, if we take a look, if we use Iptables with the -L option, we're going to see all the rules that we have. In this case, we have none associated with the filter chains. We can see here three chains: input, output, forward. Input chain. The rules that you associate with the input chain will be rules applied to packets that have your machine, in this case, this machine, as the final destination. Packets that are sent to my machine. Now, rules that you associate with the output chain will treat packets that are being generated by this machine and being sent out. My machine is the source. Packets that are arriving to my machine but does not have my machine as the final destination, and my machine will just have to forward those packets, will be treated by the forward chain, which means that the rules that are associated with the forward chain will be applied to those packets. Now, what are these rules? The rules are nothing more than a pattern that you create trying to match specific required packets. For example, once again, SSH. I have my SSH server running here right now, right? Let me install the Nmap tool. This is another very important and resourceful tool. It allows you to scan ports, verify which, well, actually it allows you to do a bunch of stuff, but mostly its most important feature is showing open ports. So let me port scan my own machine, which is this one. Okay, I can see that I have a web server running, port 80, and I also have port 22 running, open. That's my SSH server. Okay, since I do not have any rules in my input chain and my policy is accept, which means that, well, if there is no rule matching a specific packet, the default policy will be applied, which is accept. So, well, I don't have any rules in my input chain, which means that all packets that are sent to my machine will be accepted, at least in regards to my firewall. That's what Iptables is. It's a firewall. It's filtering packets. Okay, so that means that anybody from any location, any machine can try to connect to my SSH server. Now, just make it clear, the authentication and authorization process is taken care by the OpenSSH server package itself, which is actually using PAM. So it doesn't have anything to do with Iptables. Authentication, authorization goes up there in the application layer. Iptables works on the network layer. So if someone tries to SSH my machine, that person will be able to do so. There. Let me exit. What if I create a rule? So I am going to create a rule. This rule, I want to add that rule to my input chain because I want to add a rule that will treat packets being sent to my machine as a final destination. And I want to treat packets that are going to port 22. And I want to make sure that if that source is 10.0.2.15, this should be dropped. Okay, so let's take a look at it again. I want to add a rule to my input chain, which treats packets that are sent to my machine, coming from this IP address and having port 22 as the destination, which is the SSH port, should be dropped, which means that guy cannot get connection. Let me list my Iptables rules once again. Okay, so now, there, I have that rule. Let me try to connect once again. Nope, doesn't work. So I have this new rule that blocks me from doing that. Any other IP address. So let's say that I try to do the same, but using my loopback IP address. Yes, it works. There it is. Let me go back. So I blocked this IP address right here, but I did not block this one. So then I was able to. Okay, if I do the same rule now to blocking 127.0.0.1 and I try to do it again, no, I can't. Now, there is a bunch of different combinations that you can apply with Iptables. You can specify source IP, you can specify source MAC address, destination IP, destination MAC address, source port, destination port. You can use protocols. You can block or accept based on content of a packet, but you have to use modules. And that is another very useful resource that we have in Iptables. It supports so many different modules. So if you need to, or if you're curious, search for Iptables Modules. You're going to see so many different modules. Just to list a few examples, you have a module to specify a range of IP addresses. You have a module to specify the content of a packet. You have a module to specify MAC addresses. So many different modules. You have a module to specify the TCP flag header field. You have a module that will allow you to say, okay, if I have a packet that is associated with a previously established connection, I can just accept that packet because the connection associated with it has been established in the past, so that's okay. So many different modules. And just analyzing the policy here, the proper way to configure a firewall, Linux firewall, using Iptables is to actually do the inverse. For the forward and the input chains, you don't have to do that for the output chain. But for the forward and input chains, you have to define the policy as drop and not accept. So use -P, the chain, which is, for example, input, and then the default policy. Oops. There. Iptables -P, the chain name, it's case sensitive, it's case sensitive. Now we can see here that my policy is drop. Well, which is actually, right now, my machine cannot do anything. Why? Because it's dropping everything that comes to my machine. For example, if I try to browse, well, when I'm trying to browse, I'm sending a request, so it's using the output chain, but that server, once receiving my request, will reply to my request. That reply will fall within my input chain, and my input chain is dropping everything. Why everything? Because I only have two rules here, and both rules are drop, which means that they're useless, and they're associated with the SSH protocol. So Iptables is receiving a packet sent by a server, and that source port is port 80. That's the web server port. So there is a packet coming from port 80. It's looking for a matching rule here, a rule that matches that packet. No, this one doesn't match. This one doesn't match. There's no more rules in my input chain. What does it do? It will implement the adopt the drop policy. So, what is the proper way to do it? You define the policy as drop, and then you add accept rules according to what you want to accept. For example, I want to add a new rule to my input chain. Packets that are TCP packets coming from source port S, source port 80. That's how web servers reply. You send a request to their port 80. They will use port 80 to send that reply. So when that packet comes back to my machine, that packet has port 80 as the source port. And now I accept it. Okay. Well, it's not very helpful yet because I just have this rule, accepting whatever comes from port 80. But it's still not very helpful because my machine has to use the DNS protocol, so many other types of packets that I have to allow. But that is how you do it. And then you start adding rules according to the type of that packet that you want to allow. If your machine is a router, you have to add rules to the forward chain as well. Okay. Now, let's say that I already have all the rules that I need here. But the Iptables rules, they're loaded into the RAM. They're not saved by default, which means that you have to configure your system in order to load those rules when the system reboots. How can you do that? The easiest way, at least in my opinion, is you apply the rules. Once you have those rules, you do iptables-save, and then you send it to a file. Let's say firewall. if I look at the firewall file, there it is. The rules are in there. They're not exactly as the commands. You don't see iptables here. So there is a specific format. It's been generated by the iptable save tool. Okay, but it's just saving those rules in a file. What do you have to do? You have to make sure that once your system is booting, you run the iptables restore with the last sign and the file. So to save the current rules in a file, iptable save. To load the rules that have been saved in a file, iptables restore. And then you configure your system to load this file during the boot process. There are different ways of doing it. For example, you can configure the /etc/rc.local. You can create a script and configure systemd to load that script. There are different ways of doing it. So this is one way, using iptable save or using iptables restore. Another way is creating a script, and that's the subject of our next module. You create a script with all the commands that we use in our command line. You save those commands, iptables commands, in a file, save that file as a script, and configure that script to be executed every time your system is booted. So we saw here how to use several different security tools that we have available in a Linux system. We started by using Sudo. Then we analyzed the Plugable Authentication module, SPAM. And then we took a look at the evolution of the network services controllers, going from inetd then to xinetd. We looked at the APP Armor, and we also mentioned that APP Armor has kind of a rival, which is the SE Linux. Then we saw different ways of using SSH and configuring a SSH server. And lastly, we took a very good look at the iptables, which is the default Linux firewall. I hope you enjoyed this class. Thank you very much.